Problem number 5. f of xy is x minus y over x plus y. On sketch level curves, contours, this is equal to c, for c is equal to 0, 1, and 2. So when c is equal to 0, x minus y over x plus y is equal to 0. So that means the numerator is equal to 0. X minus y is equal to 0. So that's the line y is equal to x. For c is equal to 1, this is x minus y over x plus y is equal to 1. Multiply on both sides to get x minus y is equal to x plus y. And let's see here. We can cancel out the x's from both sides to get negative y is equal to positive y. This is the line y is equal to 0. Finally, if c is equal to 2, this is x minus y over x plus y is equal to 2. Clear out x minus y is equal to 2x plus 2y. And if we manipulate this a little bit, let's see here, add y, subtract 2x, so adding y gives 3y on the right, subtracting 2x gives negative x on the left here. So 3y is equal to negative x, or y is equal to negative 1/3 x. Also, I should point out here, all of these lines, they look like they're going to go through the origin, but this is not defined, for example, when x plus y is equal to 0. For example, that's at the origin 0, 0. Okay, so let's sketch these lines on a single set of axes here. C is equal to 0. That's the line y is equal to x, but we leave a little hole there. It's not defined at 0, 0. C is equal to 1 is just the line y is equal to 0. So it looks like that. But again, we leave a hole there. It's not defined when at the origin. And then c is equal to 2, y is equal to negative 1/3 x. C is equal to 2, y is equal to negative 1/3 x. So this is sketching these three level curves on a single set of axes. For part B, for a graph, what can we conclude about the limits x, y goes to 0, 0 of f of x, y? The part B, we should conclude that the limit as x, y goes to 0, 0 of f of x, y, this does not exist. Why doesn't it exist? Because this has to do with two-path rule. If we move towards the origin along this contour, c is equal to 0, the value is always just going to be 0. We move along to the origin along this contour, the value is always going to be 1. So the limit here will be 0, the limit here will be 1, the limit here will be 2. There's multiple paths into the origin that give you different values of the limit along those paths. So we use this to conclude that the limit here does not exist. Okay, that was problem 5. Problem number 6, find the directional derivative of f of x, y, z is equal to x cubed, y to the 4th, z to the 5th. At the point 1, negative 1 towards q is 1, 2, 2. How do we do this? How do we find directional derivatives? Let's see, there's several different things that we will need. First is, let's realize that we will need the gradient. So the x partial derivative is 3x squared, y to the 4th, z to the 5th. The y partial derivative is 4x cubed, y cubed, z to the 5th. The z partial derivative is 5x cubed, y to the 4th, z to the 4th. We also care about the gradient evaluated at this point, 1, negative 1, 1. So when we plug in 1, negative 1, 1, 3 times 1 squared times minus 1 to the 4th is 1 to the 5th. 4 times 1 cubed, negative 1 cubed, 1 to the 5th. 5 times 1 cubed, negative 1 to the 4th, times 1 to the 4th. What do we end up with? This will be 3, this will be negative 4, and 5. Okay, so the first thing that we need the gradient at the point P. Second thing is that we need the direction vector. So this is going from P towards Q. So we need a vector from P towards Q, and let's see here. So the first component will be 0. I'm doing the entries of Q minus entries of P. And the second one, 2 minus negative 1 will be 3. 2 minus 1 will be 1. So that is a vector going from P to Q. Now, thing to realize here is that this is not a unit vector. And the magnitude here of PQ, the magnitude is going to be square root 10. Check that for yourself. So our direction vector is going to be 1 over square root 10 times 0, 3, 1. And then to finish off the problem, the directional derivative. The formula here is going to be, you do the gradient evaluate the point dot product your unit vector. That's the direction vector. So we have 3, negative 4, 5. Dot product 0, 3, 1. All of that divided by the square root 10. And this will simplify down as 0 minus 12 plus 5 over square root 10. So negative 7 over square root 10. So relatively straightforward calculation here to compute out this directional derivative.